Hey everyone, what is going on? I'm the Savage Coder, and this is episode 10, the one you've all been waiting for. Yes, episode 10. 9 episodes in the books. 9 episodes of you learning the basics, and now it's finally time to turn that into an application. So I think that's cause for some celebration. So cool. Hey everyone, welcome back. So we're going to take everything we've learned and we're going to apply it to an application. A lot of people have reached out to me and told me that this is a part that they really struggle with, that they understand the basic concepts of programming, but they have trouble taking those concepts and applying them to a web application or a Windows application. And I think the reason that some people struggle in the very beginning is because they're missing a little bit of understanding of how the technology works and probably are most looking for a place to start. So we're going to build an application from scratch, and I've got something I can show you where I've created part of it, and it'll give us something to work towards, and then once we get to that point, we'll continue on it together. But before we can get underway, let's explain the differences between server-side and client-side web technologies, and we'll discuss which one we're choosing to use for this course and what we'll turn it into as we go forward. So let's take a look. So what is server-side web technology? Well, over here on the left, we have your computer, right? This is where your web browser runs, Chrome or Edge or Safari or whatever you use, and it accesses websites across the internet. Somewhere on the internet are a bunch of servers and possibly a database and a whole network of computers that host the websites that you normally call up. So in order to serve up a website, we have to put a folder on a server, and we have to put our code in that folder. So the server can read the code and it can process requests. When you make a request from your browser through the internet to a server, the server can analyze that request and it can look in the folder and run any code that it has to generate the web page response that gets displayed in your web browser. So let's say you're requesting HTTPS mysite.com. You type that into your browser, and DNS servers on the internet would direct that request to mysite.com to the server that handles the requests for mysite.com. In a server-side web technology, that server will read the request. In this case, there is nothing after mysite.com. We could have slash and then have some other text there, but in our example, we're just requesting the root site mysite.com. Every web server is configured with a default document to return, just in case nothing but the root site is requested. In our case, we're going to assume that the page index.html, or an equivalent default page, is read from the folder. Any code that's on that page gets interpreted, and the server renders the web page in a language called HTML. That rendered web page is returned back to the computer that requested it, and your web browser reads that HTML and assembles the web page that you're used to seeing. Let's say we wanted to log into a site. So we send mysite.com/login along with some data of our username and our password, in this case, Savage Coder and password. That request will get handled by the server. It will read the code that's in the folder for login. It may access the database and make sure that that user is using the right password, and it'll assemble the page that's supposed to be sent back, probably your home page or a profile page, or at least somewhere that can say, "Welcome, Savage Coder." And all of that's generated in HTML on the server, and it's returned to your browser on your local computer. But all the work is done on the server. So you can see that every time a computer accesses mysite.com, all of that work is done on the server. Well, that puts all of the stress and load on that server. So if we have 1 million people accessing mysite.com, we would have to put up more servers in bigger web farms, and we would have to make sure that we could handle all of those million requests at once. So we would need an infrastructure on the server side that can deal with all of that traffic. So some examples of server-side web technologies that work this way are MVC, ASPX, PHP, and Python. There are others, but those are some of the more popular ones. So now let's see what the difference is with client-side web technologies. Same setup. This is your web browser, the internet, and a server. This time we deploy two different things to the server. We have our base code, and we have an API. The idea is when we make a request to mysite.com, the server responds the way it did, but this time, instead of worrying about what it should do and what HTML it should return to the browser, it reaches out to the code folder and it returns all of the code that runs that website to the browser. So your actual code that runs is running in each client. This code is typically delivered in JavaScript, but not always. Once the code is delivered to your web browser, the browser runs the code, and the code can determine what web page it wants to create for you to see. All of the web pages that you'll need to create are in that code. There's HTML and there's JavaScript that makes decisions on what to show you, all loaded into your browser. It comes over in a very compressed format, and usually it doesn't take up a whole lot of memory in your computer. The only thing that's missing here is data. For instance, if you want to log in, the same way we did last time, you'll still need to call mysite.com/login. However, that code's going to run on your client machine. It's going to run inside the web browser. And that code is going to take Savage Coder, your username, and password, in our case, the actual password, and it's going to send those two pieces of data only over to the server that handles the traffic from mysite.com. But this time, it's going to call the API code. An API is nothing but a listener that's sitting there waiting for requests that it recognizes. So in our case, our API would have an endpoint for login, and it would expect to receive a username and a password as data. You can think of mysite.com/login as the address where it has to call out to so that it can process a login. Once the data is passed to the API it runs on the server. It'll access the database, it'll do whatever it needs to do on the server side, but what it returns is no longer HTML. We don't need HTML because all of the HTML was delivered with the code on the first round trip to the website. Instead, we just need to return the data. So in the case of a login, the data could be something as simple as, true, this is a valid user, or it could return something else completely. The code knows what to expect and can log in the user. In most cases, we'll receive some kind of a token back that represents a valid login, and we can use that token on future calls to our API so that the API knows who the user is and that they're still a valid login. One of the advantages of using client-side technology with an API, which is server-side technology in and of itself, is that we can add other types of clients. We can still have unlimited web browsers accessing our API, but now we can also add mobile devices, Windows devices, or really any type of device as long as it can talk over HTTP and call our API. The API is just going to return data, and how that data is used and displayed is going to be determined by the code that's run on your client. So yes, the code on your client on your phone is going to be different code than the code that would run on a desktop computer or different that would run inside of a web browser. They could even be, and most likely are, different languages. However, when it receives the data, it knows how to paint that screen and deal with the data and the logic behind it. So using an API-driven infrastructure, you're kind of building in protection for the future. As your product grows, you can support more and more devices, and you can support more and more users. The other great thing about using client-side websites with APIs is each user gets one copy of the code. Your computer is not going to get bogged down by some code running on your computer. It's very lightweight code that's just kind of transferring data back and forth as it needs it. Oh, I want to search for a list of products? Fine, I'll call the API and say, give me the products. The API is just going to return back some structured data, and that data will be consumed by the code to make a nice list in your web browser. So there's really no stress or load on the server side unless you have millions of clients that are accessing the API. But even then, your API isn't doing all the work of a web server in addition to the data collecting, the way that a server-side web technology does. So some examples of client-side web technologies are React, Vue.js, Angular, Svelte, which is getting much more popular, and the new one from Microsoft, Blazor. Now, Blazor doesn't use JavaScript or TypeScript like the ones above it do. Blazor runs in something called WebAssembly in the browser. But the idea is still the same. The code still gets delivered to the browser, and the code is all run on each client. So what are we going to do? What we're going to do is we're going to create a product called Savage Sell. Savage Sell is going to be a site where you can buy and sell your used items. I'm sure you've seen other apps like this already, but it seemed like something that would be fun to build. We're going to start our project with server-side web development, and we're going to use MVC. The reason that we're choosing MVC is because we can leverage our C# knowledge that we've had through the first 9 episodes in both the web side and the API side. Remember earlier when I said there's some technology that you might not understand, and that's what makes it difficult to take your basic knowledge and turn it into a web application. Some of that technology that we'll have to master when we use MVC is HTML, CSS, and some JavaScript. We'll also build a web API, and we'll use our C# skills there. We'll eventually use some SQL in SQL Server or MySQL, and we'll use the fluent filtering and manipulation powers of LINQ. One of the benefits of this is that we can use what we've learned in previous episodes, and we're going to create a platform-independent design so that after we get the basic app running, I'll show you how to port that into React, and we'll reuse the same API that we use to drive our MVC site. You can use these same techniques to use things like React Native or even native code for iOS or for Android, and you can use those tools to call the same API. So what are we waiting for? Let's get it on. All right, before we get started on creating the site, let's give a quick little demo of what it is we're going to build. Here's a basic site I'm calling Savage Sell. It has a nav bar at the top. There's a company name, and we have a home and privacy link. We'll mess with the links later as we add pages to our site. Here's the title of the site, kind of plain, but that's not what we're focusing on here. The next thing we see is a list of products. Each is displayed in a card and has a link that tells you the description, the price, and the location of the product. If we click on the link, it takes us to the product's individual page where we can buy it. Right now, this button doesn't do anything. And that's pretty much it. We have to hit the back button to go back, or we can hit home. And we also have a footer at the bottom. So let's take a quick look at the code, even though you may not understand everything you see right now. Just try and keep up for now, and we'll go through this and explain as we're building things. This is an MVC site. It has a folder of controllers. It has models. It has a service and repository pattern, and it has a list of views. In the views, we've broken things down into folders, and each folder represents a view that you can see. In our home folder, we have the index.cs.html. That would be the default page inside home, and that contains all the code to show our list of products. You probably already recognize this for each loop from C#, where it's looping through a list of products, and each product gets a card that represents it on the web page. That's each one of these. When we click on the link on the web page for the details, that code is in this view. But if you notice, the code that's inside each of these views is just what gets displayed on the web page. For instance, if we go back to our home page's index, you'll notice that we already have our list of products and we're just looping through them to show them on the web page. There's no code in this file at all that populates this list of products. That's done somewhere else. And that brings us to MVC, or Model View Controller, where our view is only responsible for creating the view. Our model is responsible for moving data from our back end into our front end, and the controller, which handles responding to the routes. Remember in the presentation in the beginning of this video, when you request mysite.com/login, there would be some sort of a login controller that would respond to that code. In our case, when you come to the default page, it calls up the index, which is the default view. From there, I create this view model by getting a list of products. I assign that list of products to a view model that I pass to my view. So the view is just responsible for taking the data and marshaling it into the web page so that it can paint a pretty picture for our users. The actual guts of getting the data exists inside a product service. Its sole responsibility is to direct traffic and manage the calls for getting data. So if we were to look at our product service, our product service has a get default products list for when you first get to the page. And then you can also get a product by an ID, which is what happens when we click on a specific product. We only want to get that product. And it calls into the repository layer, both of them do, and the repository's job is to go get the actual data. The repository would be the one that's going to call out to the API. However, in this case, I've faked it for now because I want to build the API with you. So if we looked at our product repository for get products, all I'm doing is creating a new list of product, and I'm manually just kind of faking the data and simulating an API call here. I even put a comment that this is just simulating getting data from an API. So what we're going to do first is we're going to set up and generate our two projects, our web project and our API project. And I think we'll start with the API project first, because there are ways that we can test that without going through all the things like HTML and CSS, and we can create our backend, and then depending on what you want to focus on, whether it be the website, MVC, React, mobile applications, you can use that web API to drive those other products. We'll build the simple web API, and then we'll jump back to the web side, and we'll build the consumer of that in MVC. So let's get our projects set up. So before we start creating our new project, let's go create a folder structure. So here's where I create all of my project. Let's create a new folder called episode 10. And inside here, we're going to create noble cause dot savage cell, because that's a cool namespace. And then inside there, I'm going to create two folders. One of them is going to be my UI, or my user interface, and the other one is going to be where my API lives. Now, inside the UI, we may have a few different technologies in here. We're going to start with MVC, so I'm just going to make a folder called MVC, and later we can add other front ends in there. Okay, so now we've got a place for our UI and our API to live. Let's create those. So in Visual Studio, we're going to create new project. We're going to leave the first drop down at C#, but the second one, I want to make that all platforms. And my project type is going to be web. And so by choosing all platforms, what we're doing is we're telling Visual Studio we want to look at .NET Core projects. So here's an ASP.NET Core empty. Here's a web API. So that's the one we're going to use for our web API. And then there's a couple more for the websites. There's an ASP.NET Core web app, and there's an ASP.NET Core web app model view controller, which is our MVC site. So since web API is first, let's select that one. And the name of the project is noblecause.savagecell API. And it's going to live in projects, Savage Cell API, and we'll let it live right there. Next. .NET Core 5 is great. We're not going to use any authentication for now. We may revisit this later. Do configure it for HTTPS. I'll show you how to get the certificate trusted later. And enable Open API support, because that's going to document our API for us. And do not check Enable Docker. If we get into Docker later, we'll add that stuff manually. And click Create. So I do want to mention that these, especially first beginning episodes, are going to be longer than 20 minutes. It just takes time to explain and get things set up. Once we get into actual code, we can probably keep some things shorter in time. So here's our API project. All we have are our controllers, and there is a weather forecast controller and a weather forecast site. So I'm going to leave this open. I'm just going to minimize it. What I do want to do is hit the Save All here, just to make sure everything is saved. And I'm just going to minimize this. I'm going to right-click my Visual Studio and choose Visual Studio 2019 from the pop-up menu so that I can launch another instance of Visual Studio. So now I've got two open. I actually have three because I've got some notes for myself on the other monitor. Okay, so now we're going to create our website. So create new project. Also all platforms and web, and we're going to choose ASP.NET Core Web App Model View Controller and hit next. Our project name is going to be noblecause.savagecell.ui, and it's going to live in the Episode 10, Noble Cause Savage Cell UI MVC. And next, we also want to keep the same things that we had last time. The difference here is there is no Open API choice because this is not an API, it's a website. Let's choose Enable Razor Runtime Compilation because that may help us going forward. And click Create. So most of what you saw before in our project with the controllers and the models and the views, you can see that all that got generated for us. So we didn't have to remember how to do very much to get started. And you can actually click Run right now, and it will display a default MVC site that gets created with this web template project. So yours should look very similar to mine depending on your version of Visual Studio and your vision of .NET Core. So you can see that it gave us a bar at the top, it gave us a welcome page in the middle, it gave us the footer at the bottom. There's no colors or anything like that. Your port at the top after localhost : may be different than mine. So that's fine. And this is all generated for you by default. So let's go ahead and close that browser, which will stop Visual Studio. And next I'll just save all with this guy. And I'm going to actually do a file exit on this because we're going to work on the API first. So there's a tool that we can use that's going to really make API development easier for us. And I'm all about easy. There's an industry standard tool called Postman. So if you search for Postman, if that doesn't come up for you first because Google knows me and knows this is the Postman that I want, you can type Postman space API and it'll bring up this Postman collaboration platform for API development. So go ahead and go to postman.com. What you want to do is create an account. So click sign up and create yourself an account. And once you have an account, go to postman.com/downloads. And here you can download the app. I get a better experience with the actual app. So go ahead and download and install this app. I already have it installed, so I'm just going to launch mine. All right, now that you've got Postman installed, let's go back to our API project. Currently in our brand new API project, we have the weather forecast controller and we have the weather forecast file. We're going to go ahead and delete both of those by right-clicking and hitting delete on weatherforecast.cs. Okay, delete it. And we're going to get rid of this controller because we're not building a weather forecast system, and that's just an example, even if we were. Now I'm going to right-click on controllers. I'm going to go to add, and I'm going to choose controller. None of these are the controller I want. This is an API. I'm not making an MVC site. So if I go on the left under common, I can choose API and I can make an API controller empty. That's the one we want. So click add. Now it's going to ask us for a name for our controller. There is a convention that we have to follow. First thing we're going to do is we're just going to make an API called ping, and when we call it, we want it to return Pong to us. It'll be a way to just make sure our API is up and running and it's listening for requests and responding the way we expect it to. That way, when we add functionality later, if something's not working, we can always call ping and see if we get back Pong. So the convention is to leave the word controller and replace the first part, which is values. We're going to replace that with the word ping with a capital P. So that creates, if I hit add, that will create a ping controller. So first thing I'm going to do is right-click my usings and remove and sort. Clean this thing up. So above our ping controller class, we have two attributes. The first is a route attribute, and the second is an API controller attribute. The route attribute just says that the way you talk to any endpoint in this controller is by using the path API and then the name of the controller. The name of our controller is ping. So if we went API/ping, we would be able to talk to this controller. Well, we need an action that is going to respond to our ping request. Before we can tell the controller how to respond, we have to tell the controller what the HTTP verb is. So let's take a look at the common HTTP verbs. The first and most common is get. The get verb is used when the request is only retrieving data. So if all we're doing is sending a request and we just expect some data back, we would try to use get. That's not always the case, but it's mostly the case. So in the case of our ping, we expect back just some data that says Pong, a string, or JSON data. So we'll be using a get. The other two we can look at for now that you're going to use most of the time is post. Post is used when you're changing state or a side effect on the server, such as adding a record. So think that inserting something, some new data, you post that data. And a put is kind of like an update for existing data. It replaces all current representations of the resource with the payload in the request. So the data that we send to the target is going to be used to update that target. We're going to stick with get for now. We're going to use the attribute HTTP get. And now we're just going to create a method. Public iActionResult, and I'll explain that in a minute. Get. When we call an API with an HTTP GET, we return an HTTP response code. If we look up a list of HTTP response codes, you'll see that successful response codes are in the 200 range. For instance, if you retrieve a web page or you retrieve an image or you just get some data, you're going to get back, if everything is successful, a 200 OK. If you're posting data, for instance, I'm signing up for a website and I'm adding myself to that website, that API response would probably give me back a 201 created, which means, yeah, everything worked and I created the user that you just signed up. When things don't have a response back, like, hey, could you update my username? Well, there's no data that really needs to come back for that. It just needs to let me know that, yep, I did it and everything was okay. So that might return me a 204 no content. When things don't go well, we would return an error response, like a 400 is a bad request. If we don't have permission or we're not logged in, we might get a 401 unauthorized. If we have logged in, but we just don't have permission to access that URL or that resource, we might get back a 403 forbidden. I'm sure you've all seen the 404 not found when you try to go to a web page that doesn't exist. For instance, if I go to this very developer.mozilla.org website and I just make up some garbage route and hit enter, it's not going to know what that is, and it's giving me a 400 page not found. We don't actually see the 400, but if we were to right click and inspect with our developer tools, and we would go to the network tab, if I refresh this page, we'll see in this list somewhere there is a 404 for that route. And you can see the status code that was returned is 404. And in the list was a 404. Now, other things gave me 200s. For instance, this font that they're using for this heading. And there's some JavaScript that was run, and there's some images here. Those all return just fine, but the actual request to the page failed with a 404. Okay. So what I want to do when you call this ping is I want to return a 200 OK. The response codes here are given to us by this base class controller base that our controller inherits from. And we can put any data that we want inside OK. So first, let's make sure that it works. I'm going to hit run. Remember when we chose that Open API spec? Well, the Open API spec builds us documentation as we build our API. In this case, we built a ping controller with a get, and so the path, remember I said, is API/ping, which is what this bracket controller means. And if we look at our Swagger documentation, you can see that it created a get called ping, and if we click on that, we can actually click try it out. It tells us when we execute this that we're going to get back a 200 success if it works. So if I click execute, it actually calls the API at this requested URL, and the response it got back was a 200 with the date and some extra information. So everything worked. We can do the same thing with Postman by copying this URL and clicking this little plus sign for a new request. Our request is a get. We can choose our other verbs in this drop down, but we will have a get this time. And we're going to call the same call that the Swagger documentation made. And if we click the send button, we get our 200 OK here. But it's not really returning Pong for our ping. So let's add that code now. There's a couple different ways that we can return our Pong message. So one of the ways that we can do it is with a model. So we're going to need models anyway later. So let's right click our project, go to add and new folder and name it model. Make sure if that doesn't work for you or it doesn't want to let you do things like delete and rename, you may be running. Make sure you hit stop up here and make sure your project isn't running. And now I'm going to right click models and I'm going to add a model, which is just a class. And my class is going to be called ping response. It's going to have one public string property called response. And I will remove and sort my using statements. So we have our ping response with one property, and we're just going to now remember our namespaces here, so I have to add the using for noble cause savage cell API.models. If you don't understand the namespaces and usings, then check out episode 9. Let's actually call this ping response so that we don't have response.response. So I can now set ping response dot response, that's the property, is equal to Pong. And then I can just return my ping response as the argument to OK. Now what that's going to do is it's going to serialize that into JSON, and we'll take a look at that in a second. We'll clean this up to make it better, but I wanted to keep it really basic for the first round. So if we run that, once our Swagger page comes up, we can just hit send again. And now you can see we're getting back our JSON of response. Our status is 200 OK. So you might be asking, why am I using Postman here when I could just use the Swagger documentation? And that's because when we get into things later, we'll be adding headers and body types, and all of that gets kind of a little more difficult, especially once we get into authorizations. And so if we get used to using this when we have to do basic things, when we have to do more in-depth things, you'll already be used to using it. So let's talk for a second about JSON. JSON is a way to return structured data. Using JSON, you can represent any JavaScript object. So the open curly and close curly brace is basically an object syntax. And in quotes, you can put your properties. Let me show you an example of that. I'm just going to use VS Code as my editor. So here's my response. If I wanted to add other elements, other data elements, I could put things like first name and Savage, and then last name Coder. And if you have a more complex piece of data, like you might say addresses. So an array is represented in JSON by square brackets. And then inside those square brackets would be your first object, your second object, just like above here. So then if it was an address, I could have address, 123 street. And then let's just say zip code. I'm not going to do the whole thing. So numbers don't go in quotes. Strings go in double quotes for correct syntax in JSON. And you can create objects that hold other objects here. You could invoices, and that would probably hold an array because it's invoices. And then you might have an object inside there. Things like that. So all of this can be represented. Why is it complaining? Sorry, made a mistake there. What else did I do? Okay. Sorry, you got my... Let's just bring that back. Okay. So you can see that you can represent any object with properties and sub-objects and in this notation. And so it's a really great way that's lightweight, and you can pass data to and from an API using this JSON structure. And the way that we get objects in C# into this format and objects in this format into C# is through something called serialization and deserialization. And we'll see that as we get into things. But for now, just know that this ping response object is a class and a string response with a value, and that we can represent that in JSON. All right, let's clean this up, and we will stop here because I don't want this to get too awful long. But first, let's clean this up. So to clean this up, I can get rid of this model and just make an anonymous type. So make sure we hit stop, or it's going to give us errors. And instead of creating this whole object, I really just want this part here, the response equal Pong. And I'm just going to create a new anonymous type. This is just something I don't need after this, so it doesn't need a name. It doesn't need... I'm just going to create kind of this new generic object on the fly that has one property called response. And that's all that I need for that. And the other thing is I'm going to want this route to be different than the route for the controller. I just want to be able to pass in /ping and have it call this get method. So now I won't need API controller. So let's run this now and give it a try. If I go back to Postman now and I hit send, I'm actually going to get an error, which was a 404 not found. The reason is I'm still calling API /ping, but in my code, I specifically told it I want to just call /ping. So there's no API before this. So if I go up here now and remove the API, and now I have 2 slashes. That's maybe hard to see. I don't think there's a way in Postman to make the fonts bigger. Let's see. So now if I run it, I get back a 200 OK, and a response is Pong. I was able to make this bigger. This I don't think I can make bigger, so sorry if that's hard to read. If it's easier to read on this line above in white, I can't edit that, but at least it'll allow you to read it a little better on this video. So check that out. We set up a website. We set up an API. We put a test API endpoint in that we've called with Postman. We are returning JSON from an anonymous object. Next episode, we're going to continue with this, and we'll actually develop our object model for our list of products. We'll add our service and repository layer, and we will continue building this out so that we can feed our website with data, and then we will retrofit all of that back together. Good stuff. Hope you learned something. Hope this isn't too much all at once. I will be back soon. Should not be a week. I expect to have this stuff a little faster now that we're continuing with the same project. So play around with this stuff. Maybe change what Pong returns in yours. Try out your Swagger documentation. Try it out with Postman. Have fun with it and practice, because practice makes perfect. And I'll see you online.